I'm gonna hit record so we could send you the recording of this training later. So welcome everybody. My name is Itzel Torres and I'm with 3C Ren. Before we get started, we'll go through some housekeeping slides. Today with us we have Jennifer Rennick and Grant Murphy from Imbalance Green Consulting, and they'll be talking to us about batteries. So more to come from them in a little bit. Next slide, please. So by now we all know you are all super similar with and oriented with Zoom, but we ask and we make sure that you're on mute throughout the duration of the course. If you would like to verbally participate, please raise your hand in the participant section and we will call on you to unmute yourself. And we encourage you to ask questions in the chat box and we'll get to those too. Next slide. A few words about who we are. If you're new to our programs, we are the Tri-County Regional Energy Network, 3C Ren. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working on promoting energy efficiency in our region by offering programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which we collect through the public goods charge found in our utility bills. Next slide, please. We currently have 3 programs, the first one being the Energy Code Connect program that serves building professionals by offering Title 24 support for everyone from plans examiners and inspectors to architects and contractors. Within the Energy Code Coach program, we offer the Energy Code Coach service and over the phone, online, and in the field support for Title 24, and also trainings. We have our building performance training program, which is another program where we offer services, just like trainings to building professionals such as architects, engineers, contractors, and real estate. And we also work on marketing and communication techniques within that program. Next slide. And our last one would be our home energy savings program, which incentivizes contractors and helps residents save money and makes their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass it along to Jennifer to get us started for the day. Thank you.
Thanks, Itzel. Hi, everyone. I'm Jennifer, and Grant Murphy, who works with me. They'll be here chiming in, monitoring the chat. If you have questions, put them in the chat because Grant is able to get you responses quickly, and he'll also stop me if need be. We can explain something on the slide if you have questions about it. I forgot to note it on this slide, but it's all this course has AIA units and ICC units, correct?
Just AIA.
Just AI. Okay, AIA units. Great. Anything you want to say about yourself, Grant, or just keep going?
No, just keep going.
Okay. So today's class, really, batteries. Batteries are a form of energy storage systems. And I know a lot of the folks on the call right now, architects, a lot of us are in the building trades, and we will see the acronym ESS for energy storage system or systems. And then a lot of times, if it's battery, as in a chemical battery, you'll also see it called BESS. So I want to clarify that and remind everyone that's what it means. Now, when it comes to chemical battery energy storage systems, they come in a variety of scales. So we have, on the right-hand side, we have small battery systems that are meant for private homes. We've got larger battery systems that are meant for multifamily, hospitality, or can be used, that way. That you can group up these batteries, and companies compile or, put them together with different technologies, different chemical technologies, and they're able to have large batteries that can act as backup or grid stabilization for large commercial and industrial complexes, and even larger yet, they're rolled out on a utility scale to help stabilize the grid. And we'll talk a little bit more about that on a slide after next, what I mean by stabilizing our energy electric grid. So, brief background. For a long time, as we were rolling out solar energy, solar panels, and becoming less dependent on fossil fuels in that case, the energy produced by those solar panels, if they were not used by the building, that energy was exported to the electric grid. And for a long time, that was a great thing. And the electric grid, in effect, was the battery for our solar PV systems. So in a single family example, this shows the predicted electricity energy use per month, kilowatt hours. You're going to see kWh a lot throughout. That's kilowatt hours. And that's the same metric that's used on your utility bill. And the amount of energy, say for a residence, would be up highest in January and December and very low in the summer months for a home in the San Luis Obispo County area, for example, and same, pretty typical for Santa Barbara area as well. Then we would have a solar system designed to produce just as much energy at the end of a year that this house would consume during the year. And we were calling that a zero net energy house, a zero net energy design, and we would size those solar system to meet that energy need of the house. We effectively were designing these in the past few years so that the electric grid was the battery. You could pull energy from the grid when your solar system wasn't producing, and you could feed back that extra energy in the summer during the day when you didn't need it to the grid. Now we're at a point where in California, the grid needs the battery. So take a look at this chart. It's known as a duck curve. The reason it's known as a duck curve is because a lot of people think the shape of the year's energy profile through a kind of a standard day looks a lot like a duck. So it got the nickname duck curve. And what we're seeing in California is that throughout the day, starting at 12 a.m. on the bottom axis, 12 a.m. throughout all the way up to 10 p.m., 11, back to 12, our energy use, net energy use during the middle of the day when we have a lot of solar is flat. In other words, Californians are using as much energy as our solar energy is producing. However, there's a super steep curve later in the evening as solar energy production drops off and household energy use goes up radically. And then in order to help mitigate that, California is looking to flatten the bottom of that duck curve by introducing energy storage systems. And some of those are those utility scale chemical battery rollouts. It flattens the bottom of the duck curve, and then it provides stored energy in the evenings when it's most needed. So that's kind of the background and the reason now we're seeing batteries as a requirement for high-rise multifamily and non-res occupancies that trigger a PV system large enough and a battery size system large enough. So there's minimum thresholds, but if those are triggered, then batteries are required. Now for are single family occupancies. Batteries currently are not required by the energy code, but there's a lot of compelling reasons why people are starting to install batteries. And a lot of that has to do with load shifting and capitalizing on what self-utilization credit, and that ties into our electric rate structure. So some residences, some homeowners are realizing that if they install solar with battery, they will get a better return on their investment and sometimes save tens of thousands of dollars over the course of the life of the system, which is usually set up around 20 years. Other folks are really interested in batteries for their homes because they just want to know that they have some backup power when the electric power grid goes down once in a while. And then there's a rollout, a lot of programs for folks who are installing batteries to help with the process of stabilizing the grid by basically having distributed batteries throughout. And you can be part of a virtual power plant, VPP battery program that's administered through our local utility companies. So, and Grant, if there's questions, anyone has questions, just jump in. Now, when it comes, mostly today, we're really going to be focusing kind of on this home battery scale. And like I said, it's electrochemical batteries that we're talking about. There's different other types of batteries that we're not going to get into right now. And the market is really quite large. These are just some of the more popular brands that I'm familiar with. There's many others. A lot of them are now being designed to be modular. So you can stack the batteries up vertically and add to them, or they're set up to be where you can add batteries in behind the unit and size them as you need for your home. If we take a look at kind of that market share, and this is an excerpt from Energy Sage, it's a data set in their report. And Energy Sage is a really great resource. They've kind of made it their business to help people understand renewables, including batteries, PVs, and connect you to industry providers, as well as provide a lot of information. So they take all their data and they look at that. This is the most popular kind of share for this year. And also gives you an idea of kind of the cost difference. So one of the big questions we get a lot is, well, aren't batteries expensive? And typically the answer is yes. So one of the lowest priced battery systems out there, according to Energy Sage, and it seemed to fit with all the research I've done, is the Home Grid brand, for example, comes in at approximately $480 per kilowatt hour size of battery. So there's that metric again, kilowatt hour. And batteries are going to be sized by that kilowatt hour. So you might have a 5 kilowatt hour battery or a 10 kilowatt battery hour. And the 10 kilowatt battery hours are probably the most popular size around. And so that unit starts at around 480 per kilowatt, but the kind of the median, meaning the bulk of batteries sold, is typically pricing around 1,339 kilowatt hours per Energy Sage data. And that seems pretty consistent with what I've noticed also. So that kind of gives you an idea of the range of costs and brands. I went onto the CEC website and took a look at the listed battery products and the energy storage system products, which is right now only chemical batteries. And there was a listing of over 1,000 battery energy storage products, and they had about 500 different battery options just under that category of battery. So the market's really big. Nonetheless, when battery started to be used for home solar systems. Typically, they were in off-grid situations where the home wanted to be completely disconnected from local utility. And the type of battery that was commonly used is a lead acid battery. And it has some maintenance, but it was recyclable and had a low power density, meaning that you needed a whole bunch of batteries to have enough power for that home to make it through the night until those PVs started working again, or make it through several days before your PVs started to produce energy again. So lead acid is still an option. It's still out there. And Kilovolt is one brand I'm familiar with, and Yeti rebranded as Goal Zero. Those are a couple of brands that I was familiar with and had seen, stacks and stacks of lead acid batteries in a closet in a special room area, like a utility room, and then PV system above. That was kind of the way it was done for a lot of years. But then we now have the introduction of lithium ion batteries, which has a much higher energy density, so much smaller footprint, a lot of charge. All these things are going into lithium ion batteries are going into cell phones, laptops, e-bikes, e-scooters, home batteries. And the big kind of concern now with this technology is that some of the lithium ion batteries are combustible. And you've probably seen on the news, like people's house burning, or someone's e-bike catches fire and causes an issue, or, occasionally, I'm sure we've all had the phone or or battery that swells and overheats, and thank goodness it doesn't combust. So anyhow, the kind of more recent history is that in the home battery business, LG Chem had some home in Korea and in the US, Australia, and in Europe. There were some fires that were, and it was all pointing back to their particular type of lithium ion battery. So in the United States, there's still a consumer product safety commission recall on these. And since then, LG's rebranded for LG Energy Solutions, and they have new batteries, and you can now get a new chemistry that is not combustible. So the old kind of more typical, I'd say actually the market's like half and half. So you still have half of the lithium ion batteries that are made with nickel, cobalt, manganese, etc. There's thermal runaway is still possible. They have a high power density, but the most combustible lithium chemistries are not used in those home batteries. So there's those. And then about the other half are typically lithium ion phosphate or lithium titanate oxide. And these are non-combustible. They also have advantage that they're cobalt free. And if you've been following the news on where cobalt is mined in parts of Africa, that is problematic for those people who work in the mines, and also adds a lot of issues with supply chains. So here's a couple of examples of these other battery chemistries that are available. And then the chemistry of the batteries itself. This is a part of this background as we work towards sustainability and how to guide our clients also in the battery technology, and even ourselves. There's a big push in the industry to not be dependent on lithium itself, but especially the cobalt, nickel, and copper. They're often mined, all those minerals are often mined outside the US and come at a large environmental degradation. And typically those mining operations are in areas where the indigenous people do not have very many resources to make sure that the mining is done in a sustainable way, or that they even benefit from the mining. So part of all this is to find alternative chemistries to help fuel the electric clean energy transition. And so I just want to point out that there's a lot of big efforts, and all this is because of the Inflation Reduction Act, is that now there's monies available to really promote and put grants out there to find some alternative battery chemistries, and essentially to, air quote, mine the minerals from the used batteries. So it turns out that those used batteries have it's easier to actually mine the minerals out of used batteries than it is to mine in new sites. And so Redwood Materials is kind of leading that effort. They're out in Nevada, and they have a kind of closed loop system. They work with Tesla, that was started by one of the founders of Tesla. So there's that on the horizon, and some new battery chemistries that you're going to be seeing, brands that are just now getting started, and they're announcing their unveiling of their battery chemistries. And these are 3 companies that are manufactured now in the United States. And some of these batteries you could start to order now, and others they'll be rolling out this year. And meanwhile, the research on these alternative chemistries, sodium ion and zinc ion, is continuing. So they'll be quality batteries and be better for the environment. Now, for our design considerations, when it comes to using these batteries in our home, because of safety concerns, there's been quite a bit of work for fire safety, and I want to bring some of those things to your attention, so that when you are designing a space or location for those potential batteries for the homes you might be designing, or the multifamily projects you're working on, you'll keep these in mind and be able to reference that resource. And then as far as our Title 24 Part 6 Energy Code goes, basically the question is, are batteries desired? Because right now under the 2022 code, if they're desired in single family, they're not required. You're mostly going to be following what you need to do under the electric code and for fire safety. But if it's a non-res project and a multifamily of a certain size, then batteries are required. Before we get kind of into some of these design considerations, I wanted to briefly go over some of the common equipment for a solar plus battery system. Because as a designer, when you're working with your client, you obviously, as an architect, you're not going to be designing the energy system, but it's a good idea to have an idea of what type of equipment's required and about how much space is going to be needed. So there's typically, your battery and your, in this case, Tesla calls it a gateway, but a lot of times it's your battery and kind of the controller gateway. And in many instances, it's all in one packaged up unit that you can buy, or it could be separate entities. You'll have your inverters located somewhere that either singular or multiple inverters that connects to your PV panels. And then you're going to have your main load center, or you could have backup panels for critical loads. And then you may need a separate AC disconnect, or it could be a manual disconnect that's part of your main service panel. And oftentimes you'll have EV charger. So this diagram kind of shows all the parts and pieces you could have, where a lot of battery product systems are combining some of these into smart panels and may need a little less space. But good rule of thumb is about 10 feet wide and 6.5 feet tall, although you can go higher as needed, but you want to be able to reach everything and access it. So on those general design considerations, it's possible that you can install the battery and all of the components that go with it. Like in this example here, outdoors, it can be kind of mounted against a backer board like that, or it can be mounted on an exterior wall of the building. You do need to protect it from impact damage. You can't, if you're near vehicular traffic, you're going to have to put up traffic barriers, because the batteries are really sensitive to puncture damage if they're of the combustible lithium type. You want to protect them from temperature extremes. They often have an operating temperature that does not exceed 120 degrees often. You want to protect them from adverse weather and freezing weather as well. And then you want to maintain a 3-foot distance from paths of travel, doors, and windows. And then you're going to follow the manufacturer's installation requirements. Well, that's kind of basic. For the fire safety, I've just pulled out some highlights for you, and you're going to get a copy of the slides, by the way. Highlights from chapter 15, which specifically deals with 1 and 2 family units and townhouses. Each of those individual energy storage units or chemical batteries, each, I said 10 kilowatt hours is the most popular size. They do make them bigger, quite a bit bigger, but for residential, 20 kilowatt hours stored energy is the max you're allowed to use in one compact unit. And then you're supposed to separate each of those batteries by 3 feet unless that battery manufacturer has gone through all the mass fire testing and has proven that their batteries can be installed closer together, and then they specify that minimum distance. And so the authority having jurisdiction can look at that and let you install the batteries closer. But rule of thumb, as a designer, I would just count on 3 feet separation between the batteries, especially if you're having the lithium, nickel, cobalt type of battery chemistry. And then there's going to be an aggregate size that you're not to exceed depending on its location. So if you're going to create a utility closet or storage space, for example, you can't exceed 40 kilowatt hours. And if you're going to be putting it in your garage or a detached accessory unit or install it outdoors, 80 kilowatt hours is the maximum amount of battery storage you're allowed to have in that situation. And then all your utility spaces in your garage, any place you have a battery that's indoors, which is going to have 5/8" type X gypsum board for the walls and the ceilings, and it has to be interconnected to the smoke alarm system throughout the dwelling, including the attached garage. And you want to maintain that 3-foot clearance from all windows and doors, and I would include walkways. For the 2022 Energy Code single family, this is only applicable new construction, and batteries are not mandatory. They're voluntary, but it's a mandatory measure in new construction that you are battery ready. And by battery ready, it means you've located the future isolation equipment or transfer switch with all the installed raceways that's then going to go to that battery and its controller and the rest of that system. And a sub-panel for branch circuits with a dedicated raceway that at a minimum has 4 branch circuits. And those should be identified as feeding the refrigerator, light circuit near primary egress, a sleeping room receptacle outlet, and then, owner choice for the 4th or more, depending on your battery system. But that's the minimum for battery ready. Now, under the 2022 Energy Code, high-rise, 4 stories or more, multifamily, and non-residential, battery systems are now required if they trigger a certain minimum threshold. And the occupancies that this is applying to are like grocery, retail, restaurants, schools, warehouses, hotel, motel, office, medical clinic, etc. And that battery system itself will depend on the size of the PV system itself. Now, the next few slides are going to be math heavy. I like math, so I put it into the slides. I think it's useful because this is how it's going to answer the question of like, well, gosh, how much battery is this project I'm working on going to even need, or will it even need battery? So this is going to be going to give you some of the highlights for this right now. If you're working on, multifamily and high-rise and non-residential projects. In the Energy Code, there are equations and tables and methodology for how you can calculate your minimum PV system size for those occupancies. And it's determined by your climate zone. And it's going to be based on your conditioned floor area and the PV capacity factor from this table, which is based on the climate zone. And that equation is going to determine in your kilowatt hours PV rated DC rating how much PV energy you need, or you're going to take your solar accessible roof area and multiply it times 14 watts per square foot and use that number. See whichever's less. You do this for single occupancy and mixed use occupancy buildings. I'm giving you these slides. You could go back and take a look at it, but I did run a quick example of the lower story in this image, the 2-story part of that project that includes a restaurant, retail, office, and that part of the building had a solar accessible roof area of 4,500 square feet. So we ran this through both equations and we came up that the PV panel system is going to be 33 kilowatts. Great. So that's your overall size. Now we need to know if we're going to trigger batteries. So there's 2 metrics, 2 equations that you use for batteries. That kilowatt hour battery size I was talking about earlier. And there's also just kilowatts, no hour on the end, just kilowatts as in a power capacity. And those 2 metrics have to be met for your battery. And as kind of a reminder, the primary function of the battery storage system is that daily cycling for the purpose of load shifting and maximizing the solar self-utilization and grid harmonization. And that's how the California Energy Commission through the Energy Code puts it. That's the reason for the batteries. And it turns out that if a battery is triggered for your project, it will be cost effective for your client. They're only requiring these batteries where you have enough of a impact that it actually will save your clients money in the long run for the life of the system. So if you end up doing these calculations and that battery doesn't even have to be a 10 kilowatt hour battery, you don't have to do it. Or if you have single tenant spaces or buildings that are less than 5,000 square feet, doesn't count. And then if you're in climate zone 1 for offices, schools, warehouses, those 3 categories are shown not to be cost effective. So let's take, for example, that same example, we have a restaurant, we have retail, and we have office. Well, first thing we want to note is that in this project, they have separate tenants and separate leases. And so we're going to take the exemption. And so we need only to calculate for the separate tenant space of 5,000 square feet or more. Okay, great. So the first metric, so our PV system associated with that is only 21.9 kilowatts. We calculate that because we have to feed it into the energy capacity equation. And we have to feed it into our power capacity equation. Let's, for example, say we do a power wall. Oh, and there's a little bit of back and forth. I know from doing these calculations that a lot of the batteries have that D factor of close to 90%. And some of the brands I've noticed are like a 0.89%, which is a round trip efficiency from charge to discharge, AC to AC. So it's often called, AC round trip efficiency, 89%. So Tesla Powerwall claims it has a 90% round trip efficiency. So this is a little more conservative calculation, but nonetheless, we took a look at like Tesla Powerwall, for example, and we've got an energy capacity of 13.5 kilowatt hours. So we compare that to 39.14. Looks like we might need 3 of those. We've got our continuous power, 5 kilowatts. So if we're going with 3 batteries, that exceeds our 9.2. And this whole system scalable up to 10 batteries anyway. So we're like, okay, consider 3 power walls as a potential solution. And now as a designer, this may not be the final design, but it's giving you an idea of how many batteries you will likely need. And then you can start to assess how much space that will require. And then when you work with your electrical engineer and your PV battery consultants, they'll fine tune that whole system for you. But as a designer, you can start to understand the space you might need and the location. So a few other things to kind of remember with batteries, and if you want to learn more about it, if you go into the reference joint appendices, specifically JA12, there's a whole section on the qualification requirements for battery storage systems. And some of these things, just to give you a highlight, is that those battery systems must be capable of being remotely programmed for charge and discharge. Also, you can have extra credits in your performance modeling if your battery system can be programmed for time of use metering or advanced demand control. And yes, the idea is that in a power outage, your battery backup system can be used for power to power up those critical loads you've determined. And then, however, after that power is restored, your battery must revert immediately to its previously programmed control strategy that met JA12. When it comes to battery resources for sizing, cost, and savings, there's it's a little complex to do it for the non-res high-rise multifamily, and to really look at that, you're going to be working with your industry partners. But for the residential and the small projects, just to get an idea of what you were talking about here, there's a lot of industry websites that have tools for battery sizing based on like typical household energy use. And I noticed some of them are also showing that you can click for multifamily or click on your business, but those, most of the websites I've checked, those aren't actually active yet. And they say, sorry, coming soon. But right now it seems like a lot of the industry is on board with the typical household energy use. There's also some websites that can help you understand like what kind of kilowatt hour you're going to be using and how long you'll be using these appliances to show you what their battery could power in your house. And then the Energy Sage website is going to connect homeowners to vetted contractors or pre-screened installers is how they put it. And then on the utility company websites, there's links to the battery and self-utilization incentives and applications and other rebates. And then PG&E links, which I really like. I'm going to walk you through this, is they have a solar calculator tool that includes battery storage. And I think that's done a really good job to give homeowners and a good idea of what the actual financial payback will be if they do solar with battery. So let's say you want to size a battery for your home. Okay, so here's an example, and I like this tool that they have for a real quick way to go Enphase. You click homeowners, then you click design my system, and it answers some simple questions, and then they start to give you an estimate of how many panels your house might need and what size battery and how many batteries are recommended if you're choosing just to save the most energy for like load shifting, or if you're only looking for backing up certain critical loads. It asks you these questions and you can answer them and give them your location of your house, and then they'll say, okay, in the case of an outage with this system, you could power a lot of things for 16 hours on that battery, or 7 days if the sun's shining, because you can recharge your battery during the day when you've got solar, and it won't diminish your battery down, so you can do it for 7 days. I thought that. So that's a good, useful tool. And then Energy Sage, as I mentioned before, it's an information hub and has pre-screened installers. And you can also reach out through this website and go through their solar calculator, and then you can get some sample results. I mean, you can get some results. This is a sample of the one I did, pretending that my house had $450 a month average electric bill. So it tells me, hey, if I install a certain size solar system, I'll have a certain amount of out-of-pocket expenses, and I can expect a payback in, 5.2 years based on my location and the utility rates. Manufacturer websites also are often showing estimates for their products' use. So this could be a useful resource as you're going around and looking and just trying to understand the capacity and duration for the use of a home battery system. So like Goal Zero, it's a Yeti. I know them as Yeti. Now it's a Goal Zero. They have they don't have a calculator tool, but they do have part of their website just gives you an idea that if you get their Yeti Home Power Pro system with 4,000 watts hours of backup power, that's enough too. And then it'll tell you, run your full-size refrigerator for the 24 hours and run your Wi-Fi connector for 20 hours. And you can make 1 pot of coffee during that power outage, which is really important. And your phones, etc. And then LG Solutions, they do it a little bit differently where it's a little more intuitive. You click on the icon of what you would like to have powered up during a power outage. And then it gives you some feedback on like how many batteries you would need to do that. So you can click your car charging, lights, microwave, laundry facility, etc. Another thing kind of to be aware of that's out there, and you might be hearing more about it, is the virtual power plant program. And right now there's multiple brands, and all the utility companies of California, and the main utility companies, PG&E, San Diego, Southern California Edison, they're all part of now this program. And then they're partnering with manufacturers to have this distributed battery connection so they could tap into those batteries during power outages and help and stabilize the grid. So, for example, Tesla Powerwall, Tesla is now part of this program, and you'd find out more information about it by getting their Tesla battery and going in through the app. And you can also find more information about participation through that manufacturer of the battery system you want to go to, and by going into the utility websites. Some batteries are qualifying utility customers for a pretty good rebate. Now, the folks that are eligible for that rebate on their battery often have to be in a particular fire zone. And I went ahead and took a look at like our Tri-County region, and I was surprised. We have quite a few areas in and around our Tri-County area that are part of Tier 2 and Tier 3 fire zones, and also part of the Enhanced Power Line Safety Settings District. So for PG&E, for example, you would go in through their websites and take a look at these maps, and then look into applying for an application for getting the rebate for battery. Now, this is a tool I quite liked through PG&E with a solar calculator, and you can get to it through guide.pgne.com. Take a look at their resources, customer resources section, and there's a solar calculator section. Click on it, click start the estimate. Then it's going to take you through information gathering. The reason I like it is because it includes energy improvements that can be accounted for in your financial calculation. For my example, I said no improvements. I just wanted to know what the solar and battery system was going to do. Then they'll ask you questions about your energy usage. Typically, if you're doing it for your own house, no, I failed to mention before that, most all these websites, you are going to put in a location. So if you're a designer, you might want to put in the location of your client, or maybe you put in your own home, but you'll need to put in some location to get started. Okay. And then in this case, I entered monthly energy use numbers that I had calculated doing some energy calculations, energy modeling. So in that first example I showed you, this residential house in the beginning, that was from a real project. So I took those estimated energy uses and I plugged it in to see what would come up. If you actually have your actual utility bills, that's going to be the most accurate, and you can do those. So I entered the kilowatt hour predicted energy use from without PV contribution for my econs. So for you energy, Title 24 energy folks out there. And then it's going to ask you questions about, based on that energy use, I tried to max out my PV system size. And so I was able to put in 14 panels to produce almost the same amount of energy as my little house was predicted to use in a year. So in that sense, it was that same curve. It was the old school zero net energy. And then now, what would it look like to add a battery? And I like this because you can fine tune the details of the battery capacity and its unit price based on actual products that you might be interested in. And then some additional inputs and kind of built-in assumptions that you can fine tune is like your installed solar unit price. If you actually know that, you can put it in, otherwise it'll default to 3 watts per watt. And then it's gonna convert that monthly energy use to a actual time of use PG&E schedule based on the location. And then it's going to give you your storage system cost. In this case, I updated it to, I modified it to just be $1,000 per kilowatt hour based on a product I saw. And then it's going to go through some other typical financials for increased costs of energy, et cetera, et cetera. And then I like that it has the next steps for making solar and a battery system a reality, because actually the whole point of all this is really our utility companies want folks to start having batteries and solar together for that grid stabilization. So they're trying to make this as easy as possible for people to see if there's a return on investment. So there's some graphic outputs you can look at. And so in this case, what's showing in the top is that solar system without a battery. The yellow is the energy use. The background, the dark color in the background is the amount of energy that would be exported to the grid, because that is the profile of my solar system production output. And then the gold part represents how much energy my building would use throughout the year typically. And then with the battery system, much more of that solar energy now is used on site. And so far less of the energy is exported to the grid. And then now we could also compare that to the electric usage. And what this shows is that now with the battery on the right-hand side, much more of the energy from my solar system is going to be used in my house versus how much of the energy from the solar grid will need to be imported into my house. And so solar with battery system definitely has less reliance on the energy grid itself, or the energy grid, to not be such a big battery for my home, for example. And then this is going to give you an output, a real quick output, and you can turn it into a report that gives you the benefits of battery storage with your solar. So solar only compared to solar and storage. And so some of the highlights is that with solar and storage, now 78% of the solar energy is used on site and not exported. Okay, so kind of bottom line though, is if you can afford the upfront costs of the battery, and in this case, it was assumed to be $13,500 cost to install the battery. If I could afford that, I would save an additional $9,000 plus over the 20 years, and it would add an additional year to break even. But I'd have very low utility bills, which is estimated to be around $82 a month. And the benefit is that I would have a battery to power my critical loads during a power outage. So, and then depending on the battery and the control system, could have some other financial benefits if I could participate in a virtual power plant incentive program. So a lot of what we're looking at for all electric battery systems is that, yes, your costs for these systems can be pricey, but there is an actual payback. And then once you break even, then that system will continue to pay you money. So I like this website. It helps to really break this down for folks to understand it better. If you have more questions about Code Coach services in general, please reach out to us. I'm going to have Itzel give you the conclusion of courses that are coming up and wrap up. And then if we have a few more minutes, I'm happy to stay on the line and answer questions. Grant didn't stop
Yep.
me
We have
during any of these.
we have a couple queued up. The first one, Yavinia, did she ask what the threshold was for requiring batteries on multifamily? I know we talked about non-res. Did you have when that triggers for a multifamily project?
Oh, it only triggers for multifamily when it's multifamily high rise, which means 4 stories or more.
Great.
So multifamily, 1, 2, 3 stories, no battery requirement. It's voluntary. It is if you desire it.
And then Julie asked, she had a really relevant question that we're seeing more of. She was wondering, when she has a single family residence and it's being added on to another to create a duplex, which is considered a multifamily by the project zoning, would that trigger the mandatory battery system?
No, there's no mandatory battery system for single family duplexes, townhouses, or low-rise multifamily. So
Right.
no
a duplex
battery.
is considered low-rise multifamily, so it would fall under that bucket
Yeah.
rather than the
And
non-res, which triggers requiring batteries.
correct. And also, the jurisdiction or the zoning may call it multifamily, but the energy code considers duplexes and townhomes under the single family code. And the fire NFPA 855 chapter 15 explicitly calls it single family, 2 units and townhouses, that chapter. So, and the energy code treats it the same way.
Greg had a cost question with the last couple slides. He was wondering if that 13,500 battery cost you used, if that included installation, or is that just a battery in a box?
In my case, included installation.
And then he was wondering if we had estimates for battery, switches, and install.
That is where you're going to want to engage with Energy Sage. And for fun, I did reach out to them, and I've already received about 5 or 6 estimates for installation of the battery size and the solar size that I had put in there. And then it would often, when I've spoken to folks about that in the past, it often rolls in the new panel, the switchgear, and everything else that makes a complete system. But you can go on to those individual websites and get just the pricing for this component, that component, but it gives you an idea. But you want to talk to an installer who can price out the whole package to get a handle on your real financial cost benefits.
Yeah, there's still a pretty big range we've seen from different systems and different installers. Neil was mentioning and asking that there's a wide range in the sophistication of battery system controllers for programmability, etc.
Yes.
How does that affect the cost effectiveness of a battery system? I'll just speak to a couple projects I've worked with where a lot of the times I've seen more sophisticated controllers and different types of, time of use, pulling from the battery, putting into the battery, that kind of stuff, uh, the cost effectiveness is not that significant on the scale of projects we're talking on, because the price of electricity and what you're compensated on the other end, it it's just not big numbers of money. When a project gets large enough, that can be significant. But you're right, those controllers just at a base level quickly get far more expensive than something simply. So the projects I've done it on, it usually comes from another reason to do it other than payback on the system. They're trying to do a specific, you know, a lot of it comes from resiliency, those essential loads, trying to be prepared for power outages of significant time, you know, from the range of minor to preppers, that's kind of where that shows up.
That's funny when you mentioned that, the preppers, because what I'm seeing too is that for the home, if you wanted to be like off grid, there are calculations beyond what I showed you, because you'll need to really assess like all your loads, how much you need to use it. Will you get enough energy to charge your batteries if the sun doesn't shine, or if it's too smoky? So there's a lot that goes into that, and how
Yeah.
you set up the critical loads. And then there are the folks who are like potential benefit to renters, or folks that know they're going to move. There's a lot of home energy systems now that are modular and transportable to use in emergency situations, as well as to use as your home backup. And they have like Delta Pro, for example, now is coming out with a whole system where you can have your controller, the whole thing, plus the portable batteries work with the home batteries, and you can move them around in your house, and you can take them with you if you're a renter. Plus, it's going to work as a whole home situation for resiliency and grid connection. So
For small scale.
For small scale, for a house,
Yeah.
Yeah. So there's just a lot. There's just a lot going on. And then the other thing to kind of realize too is I showed a lot of brands of batteries, and there's on the California Energy website, when you want to look at those products, I mean, there's like at least 500 to 1,000 different products you could choose from. But there's just a handful of companies that make the actual batteries, and then those batteries get put into the system that we buy. So it gets clad in materials that make it look pretty, and it includes their controllers and and that's where some of the cost goes. And also, if they are choosing to buy batteries, the base battery that has a really stable chemistry, is long lasting, and is the quality of workmanship there, so that you could get a battery in the whole system, say with a 10-year warranty, because I have seen some out there that only have 5-year warranties. And I've noticed there's a cost premium between those things as well.
Nancy asked if there's ways to charge the battery when the sun did not shine enough, when your PV did not generate enough to charge it. You can charge it with grid energy, assuming that you're connected to the grid. That kind of ties into Neil's question about controllers. Certain controllers will charge your battery with grid provided electricity at the cheapest time. And that used to be, for a short period of time there was a small game with the NEM agreements, the net energy metering agreements, where people were trying to maximize their electricity generated, sold, and then electricity bought. And again, the dollar value of that electricity is just so small relatively. And then now those NEM agreements have become less favorable for homeowners. So the energy sent back, you're not getting paid as much or credited as much as we used to for excessive generation. But to answer your question, yes, you can charge it with just paid electricity. That's all the questions. Anyone else have a question real quick? Otherwise, as Jennifer said, please send these into the code coach, give us a call on the line, use the web form, and you'll get one of us.
So, well, thank you, Grant and Jennifer. Just have a quick closing slide. While I'm talking, I'm going to also launch a poll so you could let us know how we did today. It's always super insightful to get feedback on classes, so feel free to answer the poll. If you have any questions for continuing education units, feel free to email me. I'll drop my email on the chat. There's one learning unit for this class available. Yeah, and be on the lookout for slides recording in your email. In the next couple of days, I'll be sending that out, and just some upcoming classes that we have lined up for this month are shown in this slide, and I'll also make sure to drop our link to the calendar if you haven't registered to that yet. And I just wanted to thank Jennifer and Grant today for being here with us and answering all our questions. So that's it for me. I'll close it out. If anybody else has any more questions, please let us know. If not, have a great day.
Thanks, everyone.
Alrighty. Have a great day, everyone. Bye.